So let us start. Good evening, everyone, and good evening, Dr. Satya Gupta, President of VLSI Society of India. Today, this has been a very special colloquium, not only just because it's happening about half an hour earlier, but also having a person like Dr. Satya is, you will see soon why I'm saying this. We are extremely proud to host such a distinguished technocrat today on a set colloquium. And I, in fact, find quite hard really to kind of introduce him today, but it's also, I think it's a great pleasure. So let me say a few words about Dr. Satya, who is going to kind of talk on the title of which is Making India a Semiconductor Nation. I know many of my colleagues on the call do understand how important this topic has been. And many of us have been talking about this here and there, how things are happening in India, why it has not happened the way it should have happened, and some historical perspective, sometimes talking about Homi Baba and his initiative and the dream that could not be fulfilled, and so many things. But I think here he's a person who will probably throw light on all these historical as well as technology aspects of this particular topic. And before I even proceed to introduce speaker, let me thank my long-term colleague, Professor Vivek Datar, who actually was instrumental in it's kind of proposed the speaker and this particular topic. And I hope he's online. If not, I think he's going to join very soon. So just to say, as I said, a few words, Dr. Satya Gupta did his BE from BITS Pilani and Masters from IIT Delhi and PhD from Virginia. It's actually Old Dominion University, Virginia. As you will see from his talk, is a real visionary, techno-visionary is the word to be used, with a huge experience and expertise that has been part of his worldwide semiconductor industry. He has been there for more than 30 years, both in US and India, associated with in various capacities. And during this period, he has been involved in, this is what I really wanted to say. In every aspect of semiconductor industry, it could include, design, all the way from microprocessors, system on chips, wireless chips, high performance, supercomputing, and so on. Semiconductor and electronics manufacturing, which includes fabs, packaging, testing, EMS, and so on. IP development, CAD tools, and associated industry and academic ecosystem. So he actually spanned the entire spectrum of technology and management and whatnot and policy making in the government initiatives. So after a long corporate career at Intel, he has co-founded 5 successful startups, not one. And the focus of all these startups have been semiconductor design and high volume manufacturing, intelligent electronics products for energy efficiency, automation, medical electronics, and technologies for environment. All of them are very, very current and very important aspects. In fact, one of them, Open Silicon, was actually awarded the best privately held semiconductor startup by GSA and was actually acquired for about $250 million. Currently, he's actually working on a new initiative, EPIC Foundation, which is actually a non-profit organization working towards developing Indian electronics products of national importance. Okay. Of course, in addition to all this, he still finds time, and he's been very active in building semiconductor and ESDM ecosystem, and one of the most ardent champions for building semiconductor product design and manufacturing in India for many years now. And he was a founding member of the India Semiconductor Association, it's called ISA, in 2005, and has been closely involved with that since its inception. So he was ISA's chairperson for 2012-13, 2020-21, and he has been part of many, many policy initiatives, helmed the first semiconductor manufacturing study and India microprocessor reports and so on and so forth. So in fact, his other aspect is toward building the academia industry connect, which we keep talking every now and then, but hardly anything really goes effectively in that. He has been serving as president of VLSI Society of India, which is in fact the largest platform dedicated for building research and industrial connects. For more than 35 to 40 years, he has been closely associated with the SMDP program. in conceptualizing the DLI scheme by working with METI as well as the Invest India team. Okay. Of course, needless to say, he's been honored and held in a very, very high positions. He is holding a visiting professorship positions both at IIT Roorkee and also IIT Gauhati, and helping with research and meaningful industry academia connections as I kind of talk to you. He has been recipient of very prestigious IEEE Gordon Bell Award. Some of you, if you are aware of IEEE and its awards, this is one of the biggest awards IEEE gives for high performance computing. The first to break the teraflop barrier way back in 1993, and he has been author of about half a dozen patents and almost 40 to 50 international journals and conferences. I know this introduction was long, but I deliberately didn't want to skip a single point to really say what a person in one's life can really touch upon many of these very, very high-tech areas and big, big difference. And indeed, I want to reiterate that we are very fortunate to have him today talking on this very interesting topic. So over to Satya.
Thank you, Doctor. And thank you everybody for joining and giving me this opportunity. I really feel honored to be basically invited for this talk by ASAT and TIFR. Obviously, TIFR has been one of the most esteemed institute in India, both for basically research and technology development. So it will be good to interact more with this community to see how we can make India in true sense a semiconductor nation. So for today's talk, I'm just not going to go technology-wise deep, but more about basically what is happening in the country, what is required in the country, where we are doing well, where we are not doing well, and what needs to be done. More covering those things. Probably in some few months' time, if we get to meet in person, then we can discuss more on the technology aspects and things like that, right? So, Dr. talked a lot about history and everything. So, I would like to start my presentation with little historical note. I think most of the people in room probably have been in age group where they would have seen this movie. I hope a lot of you remember this movie, right? So since I can't get the response from the audience here, this was a movie basically called Diwar, which basically was one of the biggest game changer for basically Amitabh Bachchan's career. So there is one of the most iconic dialogue basically in this movie was "Mere paas maa hai," and few of you might remember, especially people who tend to watch Hindi movies and things like that, right? So if you put that in the current context, especially semiconductor and electronics, we have market, right? So हमारे पास market है, manpower, we have very good talented manpower both in the industry and basically research academia domain. So manpower है, manufacturing भी है, electronics we have basically some manufacturing and slowly putting the right pieces in the place for semiconductor manufacturing, right? But one thing basically लेकिन पा नहीं है. What do I mean by pa, right? For making any industry successful, the ultimate holy grail is the products, because products drive innovation, product drive manufacturing, product drive business, product drive basically future R&D, right? So while we are having basically a lot of other ingredients in semiconductor, we are still lacking a lot of Indian products in the semiconductor area. And I'll basically get little bit more detail. So just build some animation based on the historical thing, right? So if you see that today's landscape or landscape for overall electronics ecosystem, because semiconductor and electronics are very intertwined, twins each other. So if you map the complete ecosystem with the depth of the technology to the basically customers in the market, right? So let me go from top to down. India is one of the largest market for electronics products. And by corollary, if you consume that many electronics products, you consume large amount of semiconductors also, right? So we have about $180 billion of the electronics products get consumed in the country today. And the expectation is by end of the decade, it will be more than $400 billion of the electronics product. And this is driven by a lot of factors, basically, certainly a young aspirational population, lot of digital platforms which have been built, like things like Aadhaar, UPI, now health stack and so on and so forth, which is driving basically need for this electronics product. And probably we are one of the fastest growing market in the electronics, right? Now, to serve this market, we need products, electronics products to be first. So I'll say we are not very well placed in that domain, right? Most of the products which we consume in India are basically global products. What I mean by that, they are by the global companies, global brands. Approximately 92 to 93% of the electronics which is purchased by the consumers in India comes from the global brands, and Indian share maybe something like 7% or so, right? Now, for these products, we need a manufacturing capability, electronics manufacturing, call it contract manufacturing or EMS. Okay. I think in the last 7 years, India has done very well, basically in this area. On the piggybacking the policies which the government has come up in last 7 years, things like production link incentives, specs, EMC, and other things, right? So electronics manufacturing probably out of the $180 billion product which are consumed in today, about 50 to 53% of those products are manufactured in India. But I think the key things to note here, they are just manufactured in India. They are not Indian products. They are not Indian designed products. We are just doing the manufacturing for that for the global brands, most of it, right? Now, for electronics manufacturing, you need embedded software. I think we are doing pretty well there. System and product design. Also, if we look at the design only, doing as a service for other people, I think we are doing pretty well. What is lacking is designing our own products, right? So if somebody comes and tells me design this product for me, I think we are pretty well placed there. But conceiving our own product, designing, manufacturing, taking it to market, scaling, creating brand name, I think that's where we're lacking. Right? Now, as we go down the chain, next is basically semiconductor products. And probably we all know that out of this $180 billion electronics, easily about $20 to $25 billion is semiconductors out of this, right? If not more. We contribute almost negligible in terms of the Indian semiconductor products. Okay. We'll come more to it later. Semiconductor design, again, we are doing very well. I think India is one of the largest global design center for the large MNCs. Almost any semiconductor company in the world today has a design center in India. But just like electronics products, we are again kind of designing these products for others, but we have very small contribution to the products from Indian products for the media. Obviously, for the semiconductor products, you ultimately need a semiconductor manufacturing facilities, fab, and ATM. I put a basically little purple circle there because a lot of action has happened in last 1.5 years, and last 15-20 years of effort by a lot of people, including ISA and other organizations, VLSI Society. I think finally we are seeing some light at the end of the tunnel for semiconductor manufacturing, both in terms of the fab and ATMP. Right? So this is the overall landscape. So I think it's very clear that what are the two biggest gaps we have, which both relate to products. Right? Products mean Indian products, which are basically Indian brands, Indian headquarter companies, Indian design, Indian IP ownership, all of that comes with it, right? And that's why I think I thought I will focus that my thoughts and rest of the presentation more towards how do we build India as a electronics and semiconductor product nation. Because if I build just the manufacturing, then we'll be just manufacturing for other people. We will not build the right ecosystem and right basically ownership. Second is the economic benefit, especially in electronics manufacturing. If you look, right, if I look at the electronics product manufacturing, which is generally referred as EMS or contract manufacturing, right, the value addition is somewhere between 8 to 12%, which is very minuscule. So if you take an iPhone, right, which sells for about $800 to $1,000, a company like Foxconn, which does the manufacturing for Apple, will hardly be getting about $20, $25 for overall manufacturing, right? And much larger share of the market is basically, or the economic benefit, right, is taken by the product company like Apple. So Apple gross margins may be more like 60%, 70%. So and also it creates long-term sustainability and all of those things. We'll come back to a little bit. Am I audible, right? Hello?
Yes, yes.
Yeah, perfect.
Yeah, because sometimes you don't know.
Yeah. No, I'm keeping a word. Sorry.
So, as I said earlier, electronics products and semiconductor products are basically very intertwined. One is heavily dependent on other. If you don't have good semiconductor products or chip, you can't make good electronics products. And if you don't have good electronics products, where are you going to consume the chips, right? So I think both have to be generally looked together if you want to create a basically very viable strategy. So today's situation, if you look in electronics product, as I said earlier, Indian products will be about 7 to 8%, and the global products, global brands will be taking the market share of about 92%, right? And if you look at the semiconductor, it may be more like 99% global products and maybe 1% or less Indian products, which are the semiconductor chips. If I look at the combined wafer consumption in India, in terms of the 12-inch wafer, which the semiconductor products will be using, right? I don't think we consume more than a couple of thousand wafers per year, right? And TSMC alone makes about basically 3 lakhs wafer per quarter, right? So in terms of the semiconductor consumption of $22 to $23 billion, we hardly contribute less than basically a couple of $100 million across all the semiconductor companies in India. They're not many, but that's where we are, right? In the product side. So I think to make the overall government push to make India as a semiconductor nation, this situation has to change, right? Obviously, the design, capabilities, talent, and the manufacturing also has to be part of it, but those are being addressed. We'll talk a little bit more about it. But this is the most important thing which will be critical, both in terms of creating the economic value, creating the strategic value, as well as creating the pipeline to utilize any of the manufacturing facilities, whether it's electronics or semiconductor, right? Today, a lot of global companies are manufacturing here because they are getting a lot of incentive from the government in form of the electronics product, right? But tomorrow, if this product company find a destination which is giving better incentive, they will move, right? So there's no stickiness, there's no sustainability. So what we need to get to is that at least 1/3 of the consumption should be taken by Indian electronics products. When I say Indian electronics product, I mean Indian phone, Indian tablet, Indian Wi-Fi router, Indian set-top box, Indian smart meter, all of those things, right? So that is very important. And if that happens, that will also drive development and scaling of the semiconductor products, right? Today, let's say if I design a mobile phone chip, right? Who am I going to sell it to? Apple is not going to buy from me. Samsung is not going to buy from me. Oppo, Vivo, Huawei, none of these guys, OnePlus, they're not going to buy from me, right? Because they have their own supply chain, they have their own geopolitical interest and everything, right? But if I have a Indian brand in mobile phone, which is selling, let's say, 10 crore phone every year, right? Now you have 10 crore sockets where your chip can go. So to create scalability in semiconductor products, it's very imperative that we create large market for Indian electronics product also, which on a competitive basis, obviously, can consume the chips which are basically designed and manufactured in India. So that's, I think, very critical for whole success of the whole ecosystem. So if you have to create a real self-reliance in electronics and semiconductor, just painting the overall things which we need to focus. Obviously, we need to focus on products. That's what we talked for last 5 minutes, both on the electronic side where we are doing complete products and the chips and ICs which are going into this product, right? We need to have the right manufacturing capabilities and capacity because it requires large investment and so on and so forth. So both electronics, EMS, on the semiconductor side, fab, ATMP, compound semiconductor, all of those things, right? And this has to be supported by right type of the R&D which is required for the semiconductor ecosystem. More than R&D, I'll say it is more technology development also, and we will touch a little bit more on this later on. And if I say that, how do we build this thing, right? So I kind of put together a number of that we need to spend $30 billion over next 15 years across the whole three verticals, which will give a ROI of about $150 billion. Okay, and about 15% of that should go towards the enabling the product ecosystem, both on the electronic side and the chip side. About 80% of that basically goes into manufacturing because that's a large scale and capital intensive and so on and so forth. Both fab and electronics manufacturing plants are expensive, right? And 5% or about 1.5 billion goes into setting up the right type of the infrastructure to do the technology development and R&D and all of those things. And this whole investment has to be supported by skilling, both in design and research manpower development, because without people, how will we basically build the ecosystem? We need people to run the fab, we need people to design the chips, we need people to do the products, embedded software, everything put together, right? Infrastructure is needed because whenever you set up a large manufacturing, you need basically for high-tech manufacturing, you need certain infrastructure elements like clean water, clean power, gases, chemicals. Sometimes I say that a fab is not a really electronics factory, it's a chemical factory, because nothing in the factory gets used which is electronics, it's mostly chemicals and gases and so on and so forth, right? But that whole infrastructure and enabling business environment has to be met. Okay. We need to have the right mindset and focus on the product design, because I think this is one thing which all of us who come from the technology field end up missing, right? When a customer buys a product, he buys it not because of the user experience, look and feel, how does it feel, right? And again, maybe repeating myself, one of the success factor for iPhone is basically the user experience and look and feel and so on and so forth, right? So when we are building our electronics product, we need to basically focus on product design, mechanical, plastic, and RRR. I think I'll just take a minute about it after this. We need raw material like gases, chemicals, research, equipment, supply chain, build the government to government relationship. One thing I wanted to mention that if India has to differentiate in electronics products, okay, it has to make its products more reusable and more repairable. If you take today's high-end products, a mobile phone or a tablet, I think once something goes wrong, it end up going into the basically junkyard, right? E-waste. Why can't we make basically these products repairable? Second thing is upgradability. Lot of time we change our devices because 3 GB RAM is not sufficient, 8 GB RAM is not sufficient my laptop, right? If we can make them upgradable, that I can change the RAM from basically 4 GB to 8 GB very easily, then we create a longer life for these products, also create more sustainability because less e-waste will be generated and lot more employment will be created through basically repair, reuse, refurbishment. That's what the triple R means. But some of our Telugu friends might relate it to the triple R movie also. Long-term policy, government support, all of these must. Taiwan has done it, Israel has done it, South Korea, Japan, US, and more recently, almost every country is doing it. So if you look at the current government schemes to support these things, right? So just the 3 boxes which we had in the previous file, akin to that, basically 3 initiatives I'm listing here. Okay, you all must have basically heard and seen in last December 15th, we announced this semiconductor incentive policy for $10 billion. That is basically your India semiconductor mission, where 10 billion will be spent in building different kind of the semiconductor manufacturing, which includes the silicon fab, display fab, compound semiconductors, ATMP, and all the other things which are required going forward, right? The second scheme is called DLI, Design Linked Incentive. So this is about like 76,000 crore or about $10 billion. Design Linked Incentive is about 1,000 crore policy where 100 companies will be supported to develop the chip level products, right? And they will be just funded in support in many ways. One is basically obviously the funding to pay for the expenses and so on and so forth. And second is all the required ingredients like our EDA tools from Synopsys, Cadence, Mentor Graphics type of the thing, which is one of the expensive item. Support for prototype manufacturing like MPW shuttles and packaging and so on and so forth. Procurement of the IP, because today no chip, everybody designs everything by themselves. They take various IP blocks and maybe 30-40% is their content, but 60-70% comes as a pre-designed IP block. So that also will be covered into this. And then compute infrastructure. So the whole idea is that a hardware startup or a chip startup should be taken care all the entry barrier, and they can start just with the people and idea, right? Because computing is taken care of, EDA tool is taken care of, IP is taken care of, all of those things. So they can focus on what they should be focusing on, as well as basically this support will also encourage venture capitalists to invest more in these companies, because their risk is reduced, because all of these incentives put together in design link incentive may reduce the cost of developing the chip by about 60%. So now if venture capitalists put the money, he's taking only 40% risk rather than taking 100% risk. Another part of the DLI is that production link incentive. When the chip is ready and chip is to be sold to the customer, then about 4% of the volume of the sales will be reimbursed to the company. So they are getting basically 4% kind of a rebate on the products, which is good, but in my opinion, it's not sufficient, and we will talk about it. And third is chip to startup program. This is basically fourth generation of the SMDP program, which has been running by MIT for almost 2 decades. This is to do the spatial manpower development across the more than 100 institutes in India, providing them all the infrastructure, EDA tools and other things, so that we can have more trained manpower. So the C2S, a chip to startup, is the latest incarnation of that. It is targeted for technology development, training, skilling, all of those things. And we expect about 85 to 100,000 people will be trained in next 5 years during the SMDP4 or chip to startup program. So there are 3 premium schemes of the government: C2S, DLI, and ISM in the semiconductor. So do you want to take any question in between or in the end only, Professor?
Actually, there are a couple of questions on the YouTube. They can be taken at the end because they're somewhat generic questions.
Okay, sure. No problem.
There are pointed questions, I will interrupt you.
Okay, sure. So one of the important topic wherever we go is that how do we make industry academia collaboration more fruitful, more engaging, more outcome oriented, result oriented, and so on and so forth. Right? And probably there are hundreds of seminars and panels have happened on this thing, right? So there's certain expectation from this collaboration. Is it working? We have to reevaluate ourselves and see if it is not working, what do we need to tune rather than basically trying to repeat the same thing again, right? So 2 critical basically outcome of such interaction should be commercial product and successful startups, right? And third is advancement of science and technology, because this is a very fast moving field. So I think both industry and academia are heavily involved in the research. In India, for whatever the reasons may be, and we can have a debate at some point of the time, this collaboration has not resulted into great success in terms of the commercial products which will create the fiscal value as well as the technology value as well as the successful startup. We have very handful basically of the successes compared to what could be expected. So I think at some point of the time this whole model has to be looked up, and I have few basically kind of a thoughts in the next slide that why basically uh, uh, we are not getting the expected result of our investment in R&D, right? So if you look at R&D, right, it's basically two components, research and development, and we put the and in between them to make it R&D, right? But if you look objective of each one of them and the capabilities required to do each one of them are quite different, right? At least in the field which we are talking about, maybe different domains might have this basically different type of thing, right? Uh, so research is predominantly basically an area where academics, our professors, our research labs and so on and so forth, they're very good at it, right? And they should basically continue to do that, right? Whereas development is a forte of industry because you have to take some basics of the research and convert into a viable product, which basically is not necessarily a forte of a academic institute, neither is their mandate, right? Okay. So what could be done and relooked is that the research academic institutions look at a big R and a small d, okay, and industry takes basically that big R and put the big D with that, makes success product. So industry does small R and big D, okay, and the whole use of the resources should be done that way, right? If I give a lot of let's say resources to academia to develop a industry strength product, right? It is not the right thing either for funding agency or for the receiver because both of them go under stress, right? Because we are giving a job of something basically which they are not that's not the charter, that's not the basically training and so on and so forth. Similarly, if you want industry to do a long-term research, basically 10, 15 years down the road, what's happening, that's a wrong expectation for them to do, right? So if we can kind of a restructure our whole R&D in terms of the research, which is primarily focused in the academic institution, research lab, and so on and so forth, and development, taking that technology developed there to convert into product basically in the industry. Then at least I think we can hope to have some changes in the current outcome of the R&D in terms of the commercial products and commercial technology. So one of the boxes when I gave the $30 billion picture, right, was to have a dedicated research institute, right? So I'm just calling it nicer because it's a nice thing to do. National Institute of Semiconductor and Electronic Research, right? It has to be a dedicated institute which is independent of any of the basically academic institute, primarily focus on the technology development in these areas. Okay, and we have a couple of models in the world. We don't have to copy everything, but we can take learnings from them. Place like IMAC, place like CLAT, A-Star IME in Singapore, right? So one is in Belgium, one is in France, and one is in Singapore, right? These organizations have done wonderful job of basically developing a technology which is for the long-term use. They are not doing the immediate product that basically they are not saying I will make the next a chip for next 3 years. They are developing the technology like IMAC is today probably working on 2 nanometer process technology. A-Star IM is using a very basically microwave and those kind of the chips, very high-end basically technologies for that packaging, so on and so forth, right? So this has to be independent institute so that everybody from industry, from different academic institution can access these things in an equitable manner. It has to be focused on research and it has to be used both by industry and academia so that we get the right type of the output, and it has to be technology focused. It does not need to be basically like teaching focused. It can be completely technology development research organization. If we can set it up right, then we will create long-term sustainable self-reliance, because tomorrow if you are denied some access to the technology, then this kind of the institutes, right, they can basically build those technologies and create real sustainable self-reliance. Another thing which we have noticed in terms of the people development in this area, right? Most of the courses in semiconductors are only at master's level. I think it's time, considering the strategic importance of this field and the overall geopolitical situation, we need to get a better quality of the manpower to serve this field, because I think 2 years back we had estimated the next 5 years we'll need about 85,000 people. In my opinion, to serve the domestic demand and the global demand for talented professionals in this area, that 85,000 number probably today is more like 150 to 200,000 number, right? Because not just for serving the domestic needs, the whole world depends on the talent from India. So one of the idea which we proposed about 7-8 months, me and Professor Ram Gopal Rao, who was IT director then, right, to AICT to start a BTech program in VLSI. The benefit is that obviously quantity will be better and people will get interested in the deep technology from the very beginning of their academic journey. And hopefully we'll get a better quality and better quantity both, right? So this is the program. Now, after basically 6 months of consulting AICT and all the other people, okay, this program has been approved. AICT has approved basically a BTech program to start in VLSI in electronics. And hopefully by the next academic year, at least this can be rolled out on a pilot basis in maybe 20-30 institutes and scale from there and see how do we basically reap the benefit of engaging the young people in this profession. I think one of the things which basically we see three policies, C2S, DLI, and ISM, right? They are catering to three domains, but one thing we need, right? When we make these big fabs, which are like buildings, we need the occupants, right? Where are the occupants going to come from? That means the large volume chip, where are they going to come from, right? They can obviously come from the global fabless company, but in the Indian context, they will come from the Indian standard products, right? The chips which are going to come from the startup, it will take them at least 10 to 15 years to reach any basically significant volume, which will make basically any dent of the fab, right? Maybe 5 years to just establish the product, then scale and all of those things, right? So if we take few chips as an example, right? A simple LED driver chip. These are standard products. They are not, I'll not say they are cutting edge innovative products, but they are standard products which are already serving the electronics products in the market, right? So LED driver chip, we have 700 million LED bulbs produced in India by Indian companies, by Indian brands, right? A smart meter, we have 250 million demand for the smart meter in the country. Probably about a couple of 100 millions of Wi-Fi devices, not just as a Wi-Fi router, Wi-Fi goes in so many other devices. Tablet, mobile chip, smart camera chip, right? All of these are today's standard products. and they are being sold in basically tens of millions and hundreds of millions. If we can create a separate initiative to develop the products of this nature, which are more or less standard products. Wi-Fi 6 is Wi-Fi 6, right? You are not going to do basically breakthrough innovation this, right? A tablet mobile processor, maybe some this thing, smart metering chip, again, pretty much standard chips, right? But for this to happen, couple of things have to happen. Today, these chips are dominated by 5 or 6 large global fabless companies like Qualcomm to the world, NXP, NVIDIA, and so on and so forth, right? The decision to use what chip, as I talked earlier, is made by the product company. So AOPO decides to basically use Qualcomm chip, they'll use Qualcomm chip. They may not basically want to use Indian chip, right? So the electronics product is very important, right? So if we need to have this about 5 to 10 chips, which are more than 50 million consumption, let's say in India every year, right? First, we need to nurture and build Indian electronics product companies which will use these chips, right? Because without that, there is no demand. There may be consumption, but there is no demand because all the global companies buy the global these things, right? Second is that since these are not basically like kind of a breakthrough type of the chips, venture capitalists will not fund them. Development of these chips, right? If I'm making a Wi-Fi chip, why will I basically Sequoia or some large venture capitalists from them? This is a commodity chip. There is no basically breakthrough here, right? But for India, it is needed because we don't have it at all. Right? So the government has to fund the development of such chips, right? Third point is that initially, if I make a Wi-Fi chip, right? My chip will be maybe same in capability, same in features, power, everything, but I'll be 20 to 30% more expensive than somebody like Broadcom or MediaTek, right? So until unless we find a way to initially bridge that gap, we will never take off, right? I design a chip, it will sit on the shelf, right? It will not find the market because I'm 20% more expensive, right? And a electronics product company will not buy something which is 30% more expensive. And we tried with the LED driver chip. Currently, our product companies buy this chip at 6.5 rupees, right? And our cost of the chip was coming at 8.5 rupees, right? And as I said, demand is about 70 crores, right? So, but that 2 rupees, who is going to pay for that, right? Because I as a developer can't pay, customer is not ready to pay. So if government wants to build a large semiconductor portfolio for the country, in addition to spending on manufacturing, academic R&D, talent building, all of those things, they may have to think basically to invest into this so that we can have these 10, 20 chips, which will create a base for basically future of building the large scale semiconductor chips, right? Otherwise, we'll keep doing through startup, like somebody will do few thousand, somebody will 10,000, 20,000 chips, right? We have to have a different strategy for high volume chips which have different requirements and so on and so forth, right? And in my rough estimate, we need about $500,000 fund to basically take 10 chips of the national importance. Okay, they may be strategic, they may be high volume, they may be driving the important product, right? And basically fund the activities in this space, both in terms of the development cost and viability gap funding to bridge the initial gap between the global pricing and what cost we will be incurring. So I don't know how much time I took, probably too long, but
that's fine, Satya. Maybe we can summarize in about 5 minutes.
Yeah.
Then we have few questions. I think we can pick them up.
So I think this is what is happening, what is required. I think manufacturing we have put a good step forward. I think there's a lot of interest from the global community to look at India in a very positive way in this situation. And compared to the previous effort, I think this time it is more holistic, where they are basically looking at design, products, manufacturing, infrastructure, ecosystem, all of those things basically in a comprehensive manner. So I think that's a very good sign to begin with. I think basically the two important areas which need further focus beyond basically what has been done. One is this setting up a technology institute similar to IMAC, which I called NICER. And second is how do we build the high volume electronics and semiconductor products in India, which are Indian brand, Indian products, and so on and so forth, because that is going to create the volume game, which is essential for overall semiconductor industry. I think problems and challenges will always be there, but at this point of the time, I think in my 20-25 years since I looked at the Indian ecosystem, I think this is the best time. Leadership is very positive. I think the all the stakeholders, industry, academia, research institutes, they are all positive. Government, bureaucracy, there is a lot of involvement from global diaspora in various aspects of basically advising the government and really helping out. A lot of people are coming out, people like Vinod Dham, Ajit Manocha, they're all helping in their own way. And they all want this India electronics mission to succeed and put India on the map of electronics and semiconductor as a real product nation, not just a basically service provider. So I'll stop here and take as many questions as we can accommodate.
Yeah, fantastic, Satya. It's a great talk, and what I think was expected from you. Really did a great kind of travel and covered a large number of very pertinent points, and every slide had information, but at the same time also we were very happy to hear your suggestions and your thoughts on various things. I think it's very, very enriching talk. I can say that. And of course, there are already quite a few raised hands. So I request
to have an interactive. I would have loved to have this talk in person, but maybe next time.
Yeah, of course, that is a promise that you already made. Surely, we need you to come on the campus and spend some time with all of my colleagues. As I mentioned today, it has been a kind of busy day at TIFR, but I was happy that many of
fully understood. Yeah.
Okay, so let's get going, and I request the people to ask questions very briefly because we are short of time. So let me first go to Dr. Prabhakar Rao.
Hello. Hello, Dr. Satya. It's a nice talk and a nice presentation. I know you very well.
Thank you.
I was at Bharat Electronics actually. Yeah. And this, you said, the NICER Institute. Is it a proposal or is being planned?
A lot of people are talking about it. I don't think there is a particular plan at this point of the time. Government understands the need of it. I think it's not just me. A lot of people have talked about need for such institutes. I think now somebody has to put together a meaningful proposal to take it forward, which is affordable as well as basically have a right direction and the outcome based, right? So IMAC is very eager to help in setting up such institutes if we go to them to advise. So I think next 6 months such a proposal should be out there to set it up. I think initially they want to basically address the making Semiconductor Complex Limited as a viable entity, and then probably this might be the next.
Yeah, that is fine, because that such an institute should have all the facilities like a fab. to do any.
All the research facilities should be there, right? And I think in my gross estimate, about $500 million should be over the next 5 to 10 years, basically should be good enough to set up all the required equipment for manufacturing, people, so on and so forth. And one important thing, at least the way I'm thinking about is that it will require significant involvement of the global Indians to basically bring it up. Okay. So
Yeah, I have a second question. This skill development and training, for the next 5 years, we said so many engineers or so many persons will be trained. But this training is like a theoretical in IITs being given, or any experienced in the fab, those kind of manufacturing experience people are given.
see, they are more of a design related experience where people create the chips. Okay. But
Correct.
just like any other fabless company like Qualcomm and others, right?
Yeah.
Everybody doesn't have to know the fab. Only very small people work in the fab, right? Most of the other basically design the chip, get the manufacturer, test, and take it to the market. So most of the courses are targeted towards basically digital, analog, mixed signal designs and different technology aspects, right? Very few are basically on the semiconductor technology side where fabrication, lithography, sputtering, all of those things are done, right? So maybe 1 to 2 courses on this thing. But at the same time, the manpower demand in manufacturing is also not very high, right? Basically, uh,
But
India probably in next 3 to 5 years will require about 5,000 people in manufacturing.
yeah, but actually design houses have been there for the last so many years, and the design courses also have been there in
Yes,
all
sir.
the institutes, right? VLSI design courses.
Yes, sir.
What is missing is process oriented skills, in the country. That is what it was highlighted
No,
to
I
me.
think I'll kind of little bit differ. I think the product orientation, if I have to create a semiconductor product chip, I don't need to know basically how the transistor is fabricated, but the business side of the thing and the product orientation, right? So that instead of doing the design services and designing chip for others, we can design chip for ourselves, right? So if you look at the spread of the manpower, right? Probably less than 5% of the manpower goes into manufacturing, right? 90% plus goes into designing of these chips, right? But obviously, since there are no manufacturing facilities, the manufacturing training is missing. But the biggest thing missing is that who is going to create this product? And what do we need to basically have that mindset of creating the products, right? Uh, very few people are needed to know the intricacy of basically how the transistor is manufactured, right? Not that many, means we need people, but not in that large quantity.
Okay. Uh, uh, Sir, I think we should move because
Yeah.
there are still considerable number of questions. So,
Yeah, sure.
Vivek Datar, I think he had asked.
Yeah, his hand is up from the beginning, like.
Yeah.
Hello, can you hear me?
Vivek, sir.
Okay, thank you very much, Dr. Satya Gupta, for a very comprehensive talk. My question was, what actually I have two, but let me ask the first one. What fraction of the VLSI chips and maybe products would go for defense? Is that a significant fraction, or is it just consumer products that are the dominant ones?
See, in terms of the unit volume, probably it will be less, but some of the chips which goes into defense and space, they are very expensive also.
Mhm.
And moreover, since you don't get it from easily from out other places, it is certainly an important area, but it's not that it's going to make like 10-15% of the volume or something like that. But
Okay.
it's an important area, but not in unit terms, maybe a small number, right?
Okay. Can I ask the second question?
Yeah, sure.
Yes, sir. Yes.
Okay. The second one relates to this thing that you said that if you were to make a chip, I think in the you mentioned it among the 10 most important chips that India would require and so on, that it would be about 30% more expensive. Is this in spite of the maybe the excise or whatever duties that are put
There is no
on
duty on the
chips?
chip import, right?
Oh, that's zero, is it?
Yeah.
Okay. Now, is it possible that, one way is to go in for volume oriented, production, uh, attack the biggest volume that is there in the market. The other is to have some innovative things, which is not probably, either it is not there even internationally, or it is at a very low level, and start from there. Because then
Yeah,
we
those
would be the
things are
leaders in that product. Because we
those things are already being basically tackled through the DLI and other schemes, right? Those are for those kind of the schemes are for those type of products, right?
okay.
But if we just do those kind of the products, right?
Uh-huh.
We are not going to reach the volumes, right? We maybe will reach 5,000, 10,000 wafers a year type of the volume through that method, right?
Mhm.
How do we get to, suppose we put this $10 billion worth of the fab,
Mhm.
each fab will be about 40,000 wafers per month, right?
Mhm.
How we are going to consume it, even if 70% of that volume is taken by global company, even getting that 30% volume.
Right.
And second is that innovative products are good, but countries' dependence on this volume chips is very heavy.
Yeah. Okay.
Right? So if suppose tomorrow we don't get basically these chips from US or somebody else, right? US or Taiwan get under attack or something like that happens, right? Then our whole mobile industry, tablet industry will come to standstill.
Mhm.
Third thing is that we are giving that market on the platter to somebody else, right?
Yeah,
Why
yeah.
should we? It is my
But
market.
won't-
I should do something about it. Right?
yeah, I agree. But won't you get into trouble with the WTO or something? Because now the
No, I
government.
can give subsidy, right? I don't need
see.
to
Okay.
give. See, if you put duty and all those things, that's fine. But incentives are fine, right?
Okay. Okay.
Every
Thank you.
Chinese company get incentives somewhere or another. There may be innovative ways of giving the incentives, right? Like PLI, for example, right? We are giving PLI for electronics products, right?
Mhm.
But that's 4 to 5%. Suppose I make that 20%. Who is going to stop me?
Mhm. Okay. Thank you.
Okay, thanks. And there's one question from Swati. Are you there on the call? Swati Deshpande?
Yes, myself is principal, Government Polytechnic, Mumbai. We are going after 12th 2-year diploma in semiconductor after 12th science. And we are planning for that, and we are in the position to establish laboratories. Basically, we visited few laboratories also, IIT Bombay and others. And we come across that fabrication and lithography. These two labs are more important here. At the same time, one more lab, we are, this institute is an autonomous institute. We need to add one more, that is a industrial safety, that is safety for all these products. While the production, safety is also required. That is one more the subject. These 3 labs we identified for that. And we need to purchase the equipment, whatever the purchase of the equipment and all. We need some guidance from Dr. Satya also. Satya sir.
Things, right? One thing is the equipment, but
Yeah.
we are close to IIT Mumbai. They have basically all this kind of equipment. But the biggest thing for this kind of the training, which is for the technicians working in the fab, right?
Yes.
There needs to
For the
be
technician working in the fab.
yeah. So there needs to be a tie-up with some existing fabs. So after, let's say, this is, you are saying 1-year course, right?
No, it's 2-year course.
Yeah. So at least
out of this year, sorry to disturb. Out of this 2 year, 6 months, that is a 24 week in industrial training. It will be a part
that's
of
what
our
I was coming
curriculum,
to.
and it will be a sandwich pattern. Yes.
Yeah, that's what I was coming to.
1.5, that is 3 semesters in institute and 1 semester in industry.
Understand. See, in most of the industries, that the formula works well, right? In case of the fab, getting access to a running fab and people basically going there for training and all those things is very difficult task, right? So both government and couple of private industry, all of the, we are trying to see if we can get access to the fabs where we can send these people who have been trained on a small scale or a theoretical basis to go for 4 weeks. I think 6 months and those things will be very difficult to send people in the fab, right? So even if they go for 4 weeks, because see, if you look at the fab technician, their job is very well defined and it's very disciplined job.
Yes.
Right? So it does not require them basically like 6 months of training like in other fields and so on and so forth, right? Since here most of the things are very automated, the main thing they have to learn, the number one thing is the discipline of working in the fab, because that's the biggest thing. If you don't follow the processes which have been laid out for the technician, then you end up basically spoiling one lot of the wafers and so on and so forth, right? So I think somewhere around 10 to 12 week or even basically 4 week training in the fab may be sufficient for doing this thing, and rest can be basically more theoretical and small scale lab and so on and so forth, right? Because see, if we say lithography, right? Technicians don't basically invent transistors there, right? They just run the machine to produce the wafers at the end of the day, right? And for them, they will not even have the basics to learn device physics, simulations, and so on and so forth, right? So for them, it is more like ITI type of the training, but for the semiconductor area.
Yeah.
So I think for that, you should check with Mighty. We've been talking about basically talking to a couple of the fabs in Singapore, Malaysia, and all those areas. If there is some potential tie-up where I think nobody will take people for 6 months, but at least for 4 weeks, if people can go, they will learn how to run the fab.
Okay.
One last question, because we have to, we have a deadline to close, but there's one question I want to take from YouTube. This is Abna Chaudhary. It says the chip making industry is highly ultra pure water intensive industry. How India will tackle the issue of dwindling availability of water for the semiconductor industry?
Very simple question, right? Basically, if India can make the largest solar power plant in the world, we can solve the problem of pure water, right? So, I see it's a question of spending a little bit money and attention. I think it's not technical challenging problem. If we are going to incentivize $10 billion towards the manufacturing plant, it takes basically maybe 10, 20, $30 million to basically address this kind of a problem, which is fraction of the cost, right? But since there was no need so far, it has not been done. Either neither technically challenging nor financially challenging. Only thing is that the location of the fab has to be in such a place where availability of raw water is abundant, right? If you go to Rajasthan and try to set up a fab, you might have a problem. But if you are basically in other places, then you should be okay.
Okay. So I think there might be more questions, but since for short of time, so let me once again, on behalf of all of you on the call, thank Dr. Satya Gupta for his very enriching, as one of you said on the post. And as promised, we'll definitely have him on campus one day very soon, and then where we will have a much better one-on-one interaction. And so therefore, let us thank everyone. Let us thank him really for his very interesting talk. Thanks, Satya.
Thank you for all joining, and would love to come and interact with you in person and rest of the team, both IIT Bombay and TFI.
Sure.
My pleasure, my honor. Thank you so much.
Wonderful. Thank you so much. Thank you so much.
Okay, signing off, sir.
Bye. Yeah, signing off. I'll call you back this evening.